Today we're going to talk about polynomials, and we're going to begin by looking at the word polynomials. The prefix poly means many, just like a polygon is a shape with many sides, and a polyglot is someone who speaks many languages. So the word polynomials means many nomials. If a polynomial is many nomials, we need to begin by understanding what we mean by a nomial. What is one nomial? Well, the prefix for one is mono, so one nomial would be monomial. But because they overlap on the letters NO, we combine it together not to be the word mononomial, but monomial. So a polynomial is many nomials, and a single one of these is called a monomial. So that is where we're going to start today, is we're going to define what a monomial is and see some examples. A monomial comes in two flavors. The first is a number times some variables, where each variable is raised to a positive integer power. The second type of monomial is simply just a number. So now let's look at some examples of things that are a monomial and things that are not a monomial. We'll begin with the first type, 2x cubed. This is a number times a variable x raised to a power that is a positive integer. So this is a monomial. However, 2 plus x cubed is not a monomial. That's because this is a number plus a variable to a positive integer power. It needs to be a number times a variable to a positive integer power. The next example is 5 times y to the 9th power. Like our first example, this is a number times a letter to a positive integer power. However, 5 times y to the 9.5 power is not a monomial. And that's because the exponent of y is a positive number, but it's not an integer. It's not a whole number. So for that reason, this is not a monomial. Our next example is negative 6z. A few things about this is, one, the number in front does not have to be a positive number. It can be a negative, like here. And what is the exponent of z? If we don't write the exponent, that means the exponent is 1, which is a positive integer. Now compare that with negative 6 times z to the negative first power. We have a number times a variable. That part is good. The exponent is an integer, but it's not positive. For that reason, negative 6z to the negative 1 is not a monomial. And for our fourth example, we have 1/2 times a squared times b to the third. This example shows that the number in front doesn't even have to be a whole number. It can just be any old number. In this case, it's the rational number 1/2, the fraction 1/2. Also, you can use more than one letter in a monomial as long as they're all multiplied together. And here we have two variables, a and b. And if you look at the exponents, a squared, the exponent is 2, which is a positive integer. And for b cubed, the exponent is 3, which is also a positive integer. Now compare this with 1/2 a squared plus b to the negative 3.5 power. There's a lot of things wrong with this one. It's not a monomial. For starters, we are adding two terms. We have 1/2 a squared. They're all multiplied together. That's nice. But we then have a plus. And to be a monomial, all the variables and numbers have to be multiplied together. Also, look at the exponent for b. It's not positive, and it's not an integer. So this is really not a monomial. And lastly, remember there were two types of monomial, number times variables to positive integer powers, and the other kind was just simply a number. So for example, pi is a monomial, or 2 is a monomial, or 4.9. These are all monomials. We actually call them constant terms. And over here we have a smiley face. And this is just not a number. It makes me happy, but it's not a number, so it's not a monomial. Now that we know what a monomial is, let's start to see some examples of polynomials. We'll start with 2x cubed minus 5x plus 1. This has three monomials combined together. 2x cubed, negative 5x, and plus 1. 2x cubed is a monomial because we have a number times a variable to a positive integer power. Negative 5x is also a monomial because we have a number, negative 5, times a variable, x, to a positive integer power, 1. And lastly, plus 1 is also a monomial because it's a number. Let's see another example. 1/2 times a squared times b cubed plus 3ab plus 7a. This is a polynomial because it's a combination of 3 monomials. You'd also can say this has 3 terms. That's probably, easier to say. Terms has 1 syllable, monomial has 4, so you're actually 75% fewer syllables by using the word terms. What's different about this polynomial is instead of 1 variable, there are 2, a and b. And if we go through and look at each term, if we go through and look at each monomial, we can see that it does meet the definition of a monomial. The first term is a number, 1/2, times some variables, a squared, b cubed, and each variable has a positive integer exponent. The exponent of a is 2, and the exponent of b is 3. The second term is also a monomial. The number is plus 3 times a and b, and each variable a and b is raised to the first power. Remember, if the exponent is 1, you don't write it. And the last term is plus 7a. The number is plus 7, the variable is a, and like before, the exponent is 1. Now let's see a few examples of things that are not polynomials. And while I'm writing this, try to think to yourself what's wrong with it. What makes it not be a polynomial? Or what prevents it from being a polynomial? Negative 7 times x to the negative 2 power plus 8. Here, this algebraic expression has 2 terms. The first one is negative 7 times x to the negative 2. It's a number times x raised to an integer power, but it's not a positive integer. For that reason, the first term is not a monomial. Now, plus 8 is a number, it's a monomial. So it came close, but it's not a polynomial. And the next example is 4 times y to the 2.5 plus 2y plus 1. This algebraic expression has 3 terms. The first term, 4 times y to the 2.5, comes close. It's not a monomial. It's a number times a variable to a positive exponent, but it's not a positive integer. So the first term is not a monomial. The second term, plus 2y, is a monomial. Number times variable to a positive integer exponent. And the third term is a number, so that is also a monomial. Now that we've seen some examples of monomials and polynomials, and we kind of know what a monomial is, I want to introduce you to a few words that you'll hear a lot and you'll use a lot when talking about polynomials. And to introduce these words, let's look at the monomial 3 times x to the 5th. The number in front of the monomial is called the coefficient. The variable is x, and the exponent is 5. But there's another term you use when talking about the exponent of a monomial, and that is the degree. So you'll use the word coefficient and degree quite a bit when talking about polynomials. Now let's look at a monomial that has more than one variable. Let's look at negative 2 times y to the 4th times z cubed. This is a monomial. The number is negative 2, so the coefficient is negative 2. And here we have 2 exponents. The exponent of y is 4, of z is 3. When you talk about the degree is the sum of the exponents. So here, the degree of this monomial is 4 plus 3, which is 7. So the degree of this monomial is 7. Now let's look at a monomial that's simply just a number. How about 2.71828? Here, previously, if the monomial had one variable, the degree was the exponent. If it had more than one variable, the degree was the sum of the exponents. Here there is not a variable, but there's kind of like a little trick that you can use so you can define what the degree of a number is. Every variable to the 0th power is 1. So 2.71828 is the same as 2.71828 times x to the 0th power. You don't even have to use x. You could say times y to the 0th power, or any variable to the 0th power. In this case, the coefficient is 2.71828, but the exponent is 0. So for that reason, we say the degree is 0. Let's talk a little bit more about the degree. If you have a monomial with one variable, like 2x cubed, the degree is just the exponent. So the degree of this is 3. Now suppose you have a monomial that has more than one variable, like -3a² times b to the fifth. Here, the degree of this monomial is the sum of the exponents. So the degree of this monomial is 7. Now watch what happens if we look at a polynomial, like 2x³ plus 5x plus 1. Just to make life interesting, in this case, you don't add up the exponents. You have 3 monomials. Each monomial has a different degree, and it turns out for a polynomial, the degree is the largest degree of all the monomials. So for this case, the largest degree is 3, and that occurs with the very first monomial, 2x to the third. So for this polynomial, the degree is 3. And lastly, let's look at a polynomial with more than one variable. a²b³ plus a to the 7th minus 3b. Let's look at the degree of each one of these terms. The degree of the first term is 5. That's because for this monomial, there's more than one variable, you add up all the exponents. The degree of the second monomial is 7 because there's a single variable, its exponent is 7, so the degree of that term is 7. And the degree of the last term is 1, because once again, if you don't write the exponent, that means it's a 1. There's only one variable, so the degree of that term is 1. So if you look at all of these 3 terms, the one that has the greatest degree is a to the 7th, and that is 7. So we say that the degree of this polynomial is 7. And finally, I'd like to introduce a few more words you might encounter when talking about polynomials. So 2x³, coefficient is 2, the degree is 3, the variable is x, but we know that this is a monomial. Next, let's look at 2x³ plus 5x. This has 2 terms, 2x³ and plus 5x. This is a polynomial, but since there's exactly 2 terms, another word you can use, you can call this a polynomial, that's perfectly correct, but you'll often hear people call this a binomial. That's because the prefix bi means 2, like how a bicycle is 2 cycles, 2 wheels. And next, let's look at 2x³ plus 5x plus 1. This is not a monomial since there's more than one monomial. It's a polynomial. This one has 3 terms. It has 3 monomials. And you'll sometimes hear people call this a trinomial. And that's because the prefix tri means 3, like a tricycle has 3 wheels. And that's about as far as you go with the other words you'll often hear. I mean, if there were 4 terms, you could call it a quadrinomial, but no one really does. If it's 5, you could call it a quintinomial. But I can't say goodbye without giving one example that I think would be a lovely word to use, but for whatever reason, no one does. Let's look at this polynomial. So this polynomial has 12 terms, so we could call that a dodecanomial. It's a fun word to say, but unfortunately, it's not every day you get to work with polynomials that have 12 terms. Let's do a quick recap. A polynomial is many nomials. It's just an addition and subtraction. You're combining a bunch of nomials. And so we began by defining and understanding what a monomial was. A monomial comes in 2 flavors, a number times some variables to positive integer powers, or just a number. We talked about the degree of a monomial. When there's just one variable, the degree is the exponent. But when there's more than one variable, the degree is the sum of the exponents. And for a polynomial, the degree is the monomial that has the largest degree. So you just look through all the monomials, look at the degrees of each one of them, find which monomial has the highest degree, and that's the degree of the polynomial. Sometimes you'll encounter the words binomial and trinomial, and all that means is a binomial is a polynomial with 2 terms, and a trinomial is a polynomial with 3 terms.